A very good morning to all dear students. Let us discuss in our this spectroscopy class of MSc second year, Sem 4. We are going to discuss in this today class about another unit. Whatever we are having the fourth unit, the unit name is nothing but nuclear magnetic resonance and ESR, electronic spin resonance. The topic we are going to discuss here. So let us discuss the last class. We have discussed about the brief introduction of the FTR principle and how the FTR principle is going to work. And the series of lectures we have discussed the topic and the earlier offline classes and online classes together. We have discussed what we have discussed Raman spectra, IR spectroscopy, all this we have discussed. Based on this background, we are going to discuss the nuclear magnetic resonance and ESR. And this topic, the unit is divided into the two parts. First part, subtopics we are having related to the nuclear magnetic resonance. And other subtopics we are having the under ESR, electronic spin resonance. Like this, into the two categories we are going to divide, but we will not discuss about the ESR because it is end of the topic. So let us discuss about the NMR, that is nothing but nuclear magnetic resonance. NMR, nuclear magnetic resonance. Understood? Nuclear magnetic resonance topic we are going to discuss. Understood? So before going, we should know little bit background why we are going to discuss background. What is this background? The background is nothing but how we are discussing about the nuclear magnetic resonance. So inside we are having nucleus and this proton and neutron and electron is revolving around it. So what is this all the background based on the different type of spectra? We are having the Raman spectra, relay scatter. So if you try to come back the background, what we have discussed, we are permitted to discuss the relay scattering, Raman scattering. In Raman also we are divided the classical and quantum. The classical will deal with what, ma'am? It will deal only about the polarization of the molecule. Understood? So based on this background only we can able to understand. Otherwise we cannot understand what does it mean by nuclear magnetic resonance. So in here classical we know P is equal to alpha E. The polarization is the product of what? How much change in the bond angle, whatever the bonds are going to change, how much amount of the electric field. We can call as alpha into the change of the bond or molecule position is going to change. That is called the alpha. And E is nothing but what? E is nothing but electric field. The product of alpha into E gives the bond polarization of the molecule. Means change. If you are applying some external force, maybe electric field, a magnetic field, or we can call it the visible light we are sending. What will happen when you are sending visible light? The light is getting scattered into the different direction. It tries to disturb the molecule. Disturb in terms of what? Vibrations, translation, rotation, motion are going to generate inside the. This is one of the important aspects we should try to know here. The point is here, I would like to tell here, that is another. So if you are taking alpha, so E sine omega t. Omega is nothing but the angular displacement of the point. It's actually the time. So like that we are having the difference. So we will not discuss main. E naught is nothing but change. E naught is the change of the electric field. Means whatever we are applying the electric field to the molecule after absorption of this molecule is going to change. That is nothing but the E naught. Understood? So that is about the classical. And as quantum we very well know, we are in the diagram I will draw. We will not discuss more detailedly because we already discussed about the Raman very much. Infrared radiation, particularly the importance of infrared radiation, nothing but it can absorb the light. It can absorb the light and ray. Longer wavelength is there, whereas Raman scattering will take place. Absorption will not take place in the Raman. Whatever we are sending the waves, it is going to coincide or incident on the particle of the specimen and getting scattered into different directions, Stokes lines, anti-Stokes. The central line is called what, ma? The central line is nothing but the radius scattering, and left hand and right hand side is nothing but the we are calling the Stokes and anti-Stokes lines. So here what I'm trying to tell is the Raman scattering is not very much sensitive, whereas infrared spectroscopy is very much sensitive to detect the changes. Suppose some waves are going to form or coming from the stars and going to fall on the clouds. What will happen? It is getting scattered. It's getting scattered in terms of what? Before getting scattered, if metal IR I'm using infrared. Infrared, suppose I'm using what will happen now? If I'm taking a specimen, if I apply, so it is getting absorbed and re-emit. Emit is different and re-emit is different. Re-emit, the difference is emit means as same. Re-emit means absorption and absorption. So due to this, what happens? The radiation is trying to disturb the molecules, such that we can get what is the properties of this molecule after re-emit. If it is only the emit, what will happen? We are not able to generate much. This is an important property we should try to understand. So now the difference are why we are discussing all these things because this page. Now we are discussing about the NMR. So now before that we are trying to study the molecular properties by using the FTIR principle. We can able to study yesterday class we have discussed. What we discussed how the molecule is going to change or we are getting the different molecule structural formations are we are going to get depending on the formation of the waves. Understood? But the point is here what we should try to understand that whenever we are trying to send the molecules, whenever trying to send the molecules in the nuclear magnetic resonance. So let us discuss nuclear magnetic resonance. Understood? Sir, why we call nuclear magnetic resonance? We will try to discuss that also. Why it is called as a nuclear magnetic resonance? Why not magnetic nuclear resonance? Very interesting. No? And the two words, where I can use the magnetic nuclear resonance. And another name is nuclear magnetic resonance. So I will discuss the resonance also. What actually is meaning of resonance also I will try to discuss also. Here why we are neglecting this? Why we are telling this is true? Why we are telling this true? Because magnetic field will not generate unless and until we are under nuclear. If nucleus is also there, then only we are going to generate what mass? We are going to generate the magnetic field or magnetic lines. We can call here what we are going to generate resonance magnetic lines. Magnetic lines are going to generate here. But as here what happens, we are not able to generate the magnetic. Why we are not generating? Because by using the magnet, nuclear cannot be created like that. Whenever nuclear is a primary, it is a secondary. Unless if it is a magnetic field is there, nuclear is not there, what will happen? We will not get. Because the primary source is nothing but nuclear. Based on the nuclear only, we are getting the magnetic. If nucleus is not there, then magnetic field is not. So that's why we are using the name as a nuclear magnetic resonance. So let us discuss what actually does mean by nuclear magnetic resonance. First, you please note down the some fundamentals here. I will try to explain what actually the stands for the nuclear magnetic resonance. And before telling the definition, let us end the introduction part with the resonance. Resonance is what resonance means any wave if you are sending from here externally after absorption it is getting split into the two parts, upper part and lower part, like a ground state and excited, Stokes and distortion. And whatever the left hand side and right hand side, both are not same. Both are not same. The vibrations which are made, the results are nothing but the vibrations of molecules. When we are taking any atom, we are sending here. After the molecule, whatever we are having in nucleus, the nucleus is going to affected by the magnet, and we are going to generate resonance phenomena. Resonance means the output, what we are getting as the output in two forms, two different levels. That is called the actually the resonance phenomena. So resonance splitting of the beam of spectrum into two parts. There are more than two paths. Understood? That is nothing but delta E energy. If you are writing like this, understood? Dotted line is the what one? Nothing but E2 and E1. Where we are having the no field. No field. H not, we are not having. Here, uh, here field applied. If both are applied to the field applied, field applied. So these two lines, delta E is equal to E2 minus E1 by H. Understand? That is nothing but what? The difference between E2 minus E1 is nothing but delta E only by H. So this is the differences we will try to discuss. You please remember this difference is nothing but called delta E is called resonance. So why resonance? Here this line and this line is not same. Both are not at all same. Both are different. So let us now try to discuss about what actually does mean NMR, theory of NMR spectra, and how we are going to form the NMR spectra. We will try to discuss now. Now we will try to discuss about the theory of NMR and definition. So what is the theory of NMR? Nuclear magnetic resonance. We will know that stands for the nuclear magnetic resonance. So definition. Please remember definition is very important. So here spectroscopy is a branch of physics. Here the NMR or nuclear spectroscopy or NMR, nuclear magnetic resonance, is a branch of spectroscopy or physics which deals or in which you can write in which please note that nuclear magnetic resonance is what does stands. Nuclear magnetic resonance is a branch of physics or a branch of spectroscopy. Understood? In which radio frequency waves induced transition between magnetic lines of nucleus of a molecule is called NMR. This NMR is called the NMR. So I will explain that in 2 minutes. We will try to discuss with simple manner what actually the NMR. NMR is nothing but nuclear magnetic resonance. Resonance just now I explained. So spectroscopy is a branch or a nuclear magnetic resonance is a branch of spectroscopy in which radio frequency waves induced transition between the magnetic lines. So magnetic lines can be different of nucleus of a molecule is called the NMR. So simply in a nutshell we can call when you have taken the nucleus part. When you have taken nucleus, an electron is revolving around the nucleus. What will happen? When we are applying some radio waves, I am getting the radio waves. Radio waves are getting applied on the nucleus. Whenever I am applying, what happens? The nucleus is very small, very the size of nucleus is very small. If we are applying non-radio waves, otherwise what happens, the nucleus will get dispersed. No amount of output we are going to get. No amount of output. Output will be no, no output. Understood? There will be no amount of output will be there. So definitely, if you want to get the nuclear magnetic resonance, nucleus should be disturbed by using the radio waves. Understood? So what is here happening? The nucleus is getting disturbed by the nuclear magnetic resonance by the radio waves. Radio waves we are taking. The range of radio waves what mark? 10 power 7 and 10 power minus, or not minus, 10 power 7 or 10 power 9 range. These radio waves are going to fall on the nucleus, and what happens? The nucleus are going to generate the magnetic lines. The nucleus is going to generate magnetic lines by the resonance phenomena. Sir, what are the conditions we will try to discuss also? And the definition we very well know what is the definition of the spectroscopy we have discussed. What spectroscopy? Nuclear magnetic resonance spectroscopy. And how we are generating. The theory is explaining whenever we are trying to take the nucleus and sending the radio waves will absorb it and re-emit in the form of magnetic lines. In the form of magnetic lines. That's nothing but nuclear magnetic resonance. The range is as 10 power 7 to 10 power 9 is the exact range for the nuclear magnetic resonance. And what is the condition? The conditions. Conditions, very important. We will not generate the magnetic lines unless and until this satisfies the condition. The condition is the nucleus should have odd integral spin, odd integral spin, like 1 by 2, 3 by 2, 5 by 2, like this. So on, we should have the atomic orbital. If we are having this type of spins again 1 by 2, 3 by 2, 5 by 2, then only we are going to get what we are going to get the nuclear magnetic. Sir, why we are getting this? Means some rules are there. So what are the rules? Why? Because if suppose in place of this we are having the even integral spin like 2, 4, 6, 8, like this we are having, or 1 by 2, same or opposite, odd and opposite should be also there. We are having all different, not only odd, we should have. If both are -1 and +1 by 2, both are getting cancelled and the output will be 0. Whatever we are having, the output will be only straight line, not like this. Understood? Here what I meant, we are divided into T0, E2 and E1. That's why I am starting half half. Then E0 and here also E0. Same. And here splitting is taking place. In this manner, we can able to understand that nuclear which having the integral spin should be an opposite and all multiple of the spins are there. Then only we are going to get the nuclear magnetic resonance phenomenon. And why we are using the radio waves now? Radio waves are very important. Radio waves have the larger wavelength, lesser intensity, lesser frequency. So lesser frequency, larger wavelength. What will happen? Definitely we can able to get the not disturb. The nucleus will not disturb in such a manner that we can able to get the output. Or understanding. So please try to understand some critically. When I am using other waves, suppose in place of nuclear magnetic resonance and radio waves, what I am using, I am using the IR radiation. IR radiation is a shorter wavelength, but higher frequency. When I am sending to the nucleus, what happens? The nucleus is getting disturbed and getting scattered or dispersed. There will be no output except E naught, or it may not E naught also. Like that, the energy level is going to accept by the nucleus is very important. If it's going to accept the nucleus, then nucleus can level very lesser energy, but longer distance can travel 10 hours. Like this, we should travel to understand. And this is the main condition to understand about the radio waves properties also. Here we should understand more detailed explanation here. Explanation, more explanation of NMR. So the what happened here? It is divided into the two parts energy levels. Hmm? So like that, we are having no field, no field applied. Field H naught is there. H naught is what? H naught is magnetic field. Understood? H naught is the magnetic field here. Another interesting thing we should try to understand here. Otherwise, we cannot able to understand. So the main condition is suppose we are having H equal to H into mu. H is not 6.625 into 10 power minus 27. Into what is the range of radio just now radio. The range is 10 power 7 to 10 power 9. Let us consider 10 power 7 lowest value. So if you get minus both, what will happen? 10 power minus 7, right? Minus 20 hours. So like that, the energy of the radio waves you can able to generate and multiply the transforming value. Another condition to get the radio waves is important, and it is used to study the nuclear structures. Nuclear structures. Nuclear structures. At the year of 1954, I think, we got Nobel Prize. Nobel Prize. Understood? In the year of 1954, what? It got the Nobel Prize in the physics. But the scientist name is called Stanford. And Harvard are the both the scientists that got the Nobel Prize in the spectroscopy. Why? Because by using the NMR spectroscopy, we can able to study the quantitatively and qualitatively molecular structure. Quantitatively and qualitatively the molecular structure of the molecule can be studied. That is a very important thing we should try to understand. And the interesting thing, the nuclear spin. Nuclear spin. So the nuclear spin, that is nothing angular spin angular momentum, or we can spin nuclear spin angular momentum. How to calculate the angular spin momentum? So here the fundamental is I is called what? I is nothing but the spin angular momentum of the molecule. So like that we can able to understand that the spin angular momentum is nothing but what we can able to I into I plus 1 by 2. Understand? H by 2 pi. 1 by 2 is nothing but under root. Like that we can able to get the I. So here what happens, we should not to determine the magnetic moment mu. Mu is nothing but alpha into I, gamma into I. Where gamma is a gyroscopic ratio. So if I am going to multiply gamma into, I am able to get the what is the actual value here. I am going to have nothing but I into I plus 1 H by 2 into like that I am given to get the actual value of what? Of the total magnetic moment. U is nothing but the magnetic moment of the nucleus. It's gyroscopic. Gamma alpha, like this gamma ratio, whatever we are having the gyrometric ratio of the magnet, like this gamma into I into I plus 1 by 2 to H by 2, but the molecules we are going to. So orally what happened? We are going to get gamma H by 2I. That's right. Gamma H by 2 pi is the ratio of what of any molecule we are going to get by dividing by dividing by the two different types of material we are going to. In what manner we are going to do? Let us practice. So please note on that how we will discuss. So now we are having the two spins. Yes, spin what minus plus 1 by 2 minus 1. So we should prove this equation. So let us try to prove this equation. We got this value here directly. So now what is the target hour? We are having the two speeds. Then how we are going even into two different energy levels. Delta is equal to V2 minus V1. Two different energy levels we are going to get. These two different energy levels are we can able to determine, that is nothing but E1 and E2. So whatever we are having the value of mu is nothing but the, let's consider the 1 by 2, or 1 by 2 is what plus 1 by 2. Gamma h by 2 pi into h naught. H naught is nothing but the field, how much field we are going to apply. By equating this equation for the E1, for the spin of 1 by 2. For the spin of minus 1 by 2, I'm going to get gamma h by 2 pi 2 pi. It's all equation nothing but the h. Understood? So what happened now? I'm going to get the two equation. So from equation, this equation is called what now? Number 1, equation number 2, number 3. From 3 and 4, E2 minus E1 by H. E2 minus E1 what? Just substitute the values. 1 by 2, E2 minus 1 by 2, minus 1 by 2, gamma H 2 pi. Then we are having what we are going to happen, H naught. H naught we are taking the common term, last we can write. So minus actually we can get plus here, that we can write. So what happened? 1 by 2 gamma H. Overall we are having H naught. Again I have taken 1 by 2 common, gamma H by 2 pi is common term, and H naught here. So or we can write this equation in the form of 2 pi. 2 2 is cancel, 1 by 2 1 by 2 cancel, gamma by 2 by 2. So this gamma is nothing but the gyroscopic ratio, H is the Planck constant, phi is the value, H will be field. And the important thing is, I will tell you now, as much you are applying the magnetic field, that much amount of changes are going to take place. If I am applying the more magnetic field, then we are having the more changes in the molecules are going to change. More intensity is going to increase. You please note on this equation. We'll conclude this class by telling the background conclusion. So overall, what we understand, as the magnetic field is increases, if you are taken a nucleus and applying the magnetic H naught, then more magnetic lines, more magnetic lines are going to get. As we are getting the more magnetic lines, there will be a more magnetic lines will be there depending on the H naught. As H naught increases, H naught is magnetic field paradigm. What will be intensity? Intensity of magnetic lines also increases. Also increases. Like this, we are going to have two types: magnetic lines and magnetic field. You should understand in this manner. So today, overall, what we have understand in this class, we discuss about the definition for the nuclear magnetic resonance. How on the background base we got the nuclear magnetic resonance. We will not get nuclear magnetic unless and until it is interacted by the external radio waves. This is nothing but the transition of the different magnetic lines. Very interesting topic, and it is used to study about the molecular structures in quantitatively and qualitatively changes and structural changes of different. And the important aspect is last but not least, hydrogen play very important. Understand? if you are trying to take the hydrogen molecule, hydrogen is very sensitive. Hydrogen molecule, like that there are the different type of molecules. Fluorine we are having, phosphorus we are having, carbon we are having. It is sensitive to the hydrogen. Hydrogen, why it is hydrogen sensitive? Because it is having the very less atomic weight number. So then what about FPC? At least ferrous, phosphorus, carbon we are having, then we can able to get the actually 31 carbon and 30 19 atomic weight. And what happened is very sensitive to get the structural formation of the molecule and hydrogen. And last but not least, if isotopic number is same, then it is not able to get, because if I have the 13 and 13 same, both are getting minus and we are getting 0. So if you have 13 and 16, there's some difference between them. The reason. So overall, we should understand, in order to get the resonance, we should have a difference in the condition. A2 minus even by H is the this is the overall about today class. About today class, we discuss about what is the background of nuclear magnetic resonance, what is an NMR, value of NMR, and explanation of NMR, and diagram how, and equation part, expression part, how for the expression part is the very important part. So about today class, next class we'll discuss another topic of the